Kant's influence, manifesting during a century in which science rapidly usurped the speculative territory held by philosophy, was perhaps more significant in immediately reshaping the direction of philosophy than any other modern thinker. His influence was most important in establishing a new tone and attitude to the methodological approach he used, empathetic to the approach of science, yet still motivated by the philosophical ideal of theoretical inclusiveness. Kant's attitude can be discerned from the very fact that he saw his approach as criticism, and his methodology was of a critical philosophy. With a special focus on the approaches and conclusions of the rationalist and empirical schools of thought since Descartes, Kant embarked upon a reform of the past and a restated, reformulated and articulated synthesis. One of his aims was to identify the basic issues and ideas, discarding the supporting frameworks of unessential and peripheral speculation. Carus wrote this about Kant's approach. Kant took the next step in seeking for the principle that determined all thinking and discovered it in the purely formal laws of thought, which in their complete unity constitute pure reason. The investigation of the conditions of thought he called criticism. He insisted that the dogmatical declamations of all the various systems of metaphysics were idle and useless talk. In place of the old metaphysics, Kant drew up an inventory of the possessions of pure reason and came to the conclusion that purely formal thought and sense experience combined form the warp and woof of experience, which alone can afford positive information concerning the nature of objects. Empirical knowledge of the senses furnishes the material, while formal thought supplies the method by which perceptions can be organized and systemized into knowledge. Kant's aim was not to produce glittering generalities, but to offer critique, that is to say, a method of, and norm for, scientific thought. Kant's synthesis and reconceptualization of the nature and scope of philosophical inquiry thus established a new ideational framework for future lines of speculation. His influence also was felt in all spheres of thought and speculation during the 19th century. Philosophy, as a legitimating institution during this century, was most esteemed and fertile in Germany, in large part because of Kant's influence. As happens within all ideational institutions, prior to the discussions, analyses, applications of new systems of thought, a process of filtration and dissemination is required. Before wider confluence and transformational influence may be achieved, authority must become invested in those ideas by way of expert and specialist confirmation of their significance. And wider public legitimization is spread by having those ideas become part of the general intellectual atmosphere. In 1882, Heinrich Heine was able to look back and have this overview of Kant's influence on thought just about a century after the publication of his major work. I have already said that on its appearance the critique of pure reason did not cause the slightest sensation, and it was not till several years later, after certain clear-sighted philosophers had written elucidations on it, that public attention was aroused regarding the book. In the year 1789, however, nothing else was talked of in Germany but the philosophy of Kant, about which were poured forth in abundance commentaries, estimates, chrestomathies, interpretations, estimates, apologies, and so forth. We need only glance through the first philosophic catalogues at hand and the innumerable works having reference to Kant will amply testify to the intellectual movement that originated with this single man. In some it exhibited itself as an ardent enthusiasm, in others as an acrid loathing, in many as a gaping curiosity regarding the results of this intellectual revolution. We had popular riots in the world of thought, just as you had in the material world. Kant brought about this great intellectual movement less by the subject matter of his writings than by the critical spirit that pervaded them, a spirit that now began to force its way into all sciences. It laid hold of all constituted authority. Even poetry did not escape its influence. Fortunately, it did not interfere in the art of cookery. Germany was drawn into the path of philosophy by Kant, and philosophy became a national cause. A brilliant troupe of great thinkers suddenly sprung up on German soil. 2. In this quote we have a classic example of how philosophy grew in stature and credibility as an authoritative legitimating institution. A new critical but constructive attitude to the ideational framework of the past combined with fresh insight, understanding, articulation to create a more relevant and meaningful envisioning apparatus. In fashioning this system of thought, Kant used an idiosyncratic vocabulary of concepts and ideas, applying new interpretations to old terms, reconfiguring the connections between those terms, finding new speculative paths to follow. His written expression itself was dense and somewhat esoteric, requiring further explication before widespread filtration was possible. However, that somewhat ambivalent open-endedness of possible interpretation was part of the efficacy of the critical philosophy. The brilliant troupe of thinkers springing up carried on Kant's impetus in a number of specific directions. Collectively, they helped maintain the enterprise of philosophy as a primary framework of articulating and representing how reality was conceived. This occurred directly through further philosophical exploration, and indirectly, as a provocative influence on religious and scientific speculation. And the net effect was a preeminence of philosophy as an institution of esteem and legitimacy. In Germany this was most explicit, where philosophy became a national cause. However, that provocation of popular riots in the world of thought created waves of varying influence throughout the Western world. Within the field of philosophy itself, Kant's thought stimulated speculation in a number of divergent directions. Karras again comments, "The organized wealth of original and profound conceptions and of subtle analyses which is the critique of pure reason contains, of course, the seeds of many modern philosophies. Concentration on the positive doctrine of the dialectic to the exclusion of most other theses of the Kantian system leads to pragmatism. Concentration on the doctrine of the transcendental logic as a whole to the exclusion of Kant's ethical works leads to a non-phenomenalist, non-Berkeleian empiricism or positivism, provided the table of the categories is not taken too literally. Twisting the dialectic into a logic of truth leads to metaphysical systems of the Hegelian type. Even phenomenology and existentialism contain many recognizably Kantian elements." Quote, "Historically simplified, the most evident immediate impact on philosophical speculation was emergence of metaphysical systems of the Hegelian type. One line of Kantian-based thought prioritized the elevation of the ego as a spiritual entity, characterized by transcendent qualities pertaining to its noumenal source. A widespread philosophical idealism emerged as the dominant school of thought, focused on the transcendent ego, or self, perceived as the validating and ultimately significant component of experience. For example, Schelling had this orientation. I know unconditionally only that, the knowledge of which is conditioned solely by the subjective, not by the objective. In his Science of Knowledge, Fichte revealed this perspective. The source of all reality is the self, for this is what is immediately and absolutely posited. The concept of reality is first given with and by the way of the self. This envisioning of reality only acquiring legitimization by way of the transcendent rational faculties of the ego, reached its most extensive presentation in the thought of Hegel. Hegel conceived thought equal to being, the rational equal to the real. And philosophy was stated to be the perfect methodology for understanding ultimate truth. Hegel confidently assumed he had brought the activity of philosophy to its final stages, and had discerned the real meaning of existence. Lewith saw him this way. Hegel included his own standpoint of philosophical consummation, bringing the kingdom of thought to completion. According to his arrangement of the history of philosophy into periods, his own system stands at the end of the third epoch. The philosophical system of this final epoch brings about, through rational thought, the reconciliation which previously had only been hoped for. In principle, all or nothing. else than more or less complete methods of unification. At their culmination stand Hegel's absolute system. Hegel's history of the spirit is not given a mere preliminary conclusion at a random point. It is concluded, definitely and consciously. On this historical basis, its logical form is not a verdict, but a conclusion, a merging of beginning and end. This conclusion is not an arbitrary. We have arrived at this point, but rather, we are the goal, it is an outcome. Hegel's system depended on the logic of dialectical process and the unfolding of teleological evolution. Dialectical logic consisted of the phases of thesis, antithesis, synthesis to arrive at final truth. What was true applied both for the self and the world, with the laws of thought intertwined with the evolution of reality. Reality was conceived to be a whole, the manifestation of universal reason, the absolute. Considered in its objective appearance, the absolute is nature. But nature is only validated in terms of reason, as a form of manifestation for the spiritual. And reason also appeared and evolved logically through the human mind. The dialectic of mind occurred first as soul, or subjective mind, when dependent on nature. And then as spirit, when reconciled to nature. Objective mind shows itself in nature, history, human institutions. Absolute mind is found in the mental, or spiritual, way of life. The nature of man as a free spiritual being is expressed in progressively more revealing form through the arts, religion and philosophy. And the indications of the presence of absolute mind appear in such forms as history, social life, politics. Hegel idealized the philosophical enterprise as something which was potentially open to everyone, providing that the individual was willing to approach the inquiry with the right, scientific, attitude. Kaufmann summarized his opinion here. The basic idea is that the time has come for all men to demand equal access to philosophy, and to become common property philosophy must become scientific. To become exoteric and democratic, philosophy must be available to every intelligent person who is willing to shirk no effort, regardless of whether he belongs to some special group or clique. The time for special privilege is past. But it should be noted that Hegel's position does not commit him to popularization. Science, including higher mathematics and advanced physics, is exoteric and democratic in the sense here at stake. And Hegel constantly insists that philosophy requires the most serious exertion and hard work. Indeed, this is part of what he means when he considers elevating philosophy to the level of a science. It is important to note that Hegel's explicit valuation of philosophical inquiry as the most accurate means of comprehending a reality of transcendent truths was a major criterion of its legitimating function. The practice of philosophy continued to become more and more of a socially esteemed and relevant activity for the intellectual elite, encouraged through a variety of channels and circles, and helping the institution retain important legitimating status. Hegel's system, as a means of interpreting ultimate reality as appearing through social and historical forms, became pervasive in its influences. The meaning of human experience, both in personal and social contexts, was reconstructed and re-envisioned through a number of subsequent frameworks of thought, influenced by the contents and methodology of Hegel's system. And the legitimizing value and credibility of philosophy as the most authoritative way of understanding and representing reality was expressed pervasively in the intellectual milieu. In his Philosophy of Mind, Hegel expressed those lofty sentiments in these words. This notion of philosophy is the self-thinking idea, the truth aware of itself, the logical system, but with the signification that it is universally approved and certified in concrete content as in its actuality. In this way the science has gone back to its beginning. Its result is the logical system but as a spiritual principle, out of the presupposing judgment, in which the notion was only implicit and the beginning and intermediate, and thus out of the appearance which it had there, it has risen into its pure principle and thus also into its proper medium. In its pure principle and proper medium, philosophy attained its most esteemed status. As a methodology of thought, analysis, speculation, in social and historical theories and practice, in visualization of the nature and ends of human existence, in providing the framework for interpreting subjective and objective experience, philosophy was the prime legitimizing authority at this time. The varieties of religious envisioning were given relative degrees of signification as interpreted in terms of the historical evolution of spirit. The empirical sciences also were accorded degrees of both pragmatic and theoretical value, but only as encompassed within the wider theoretical system, and not as self-sufficient independent ideational vehicles. That orientation would come from outside the philosophical mainstream. The history of philosophy after Hegel moved in a number of directions. In Germany itself, there was immediate division in the Hegelian school itself, where ideological differences extended to encompass political divergence, and young Hegelians and old Hegelians respectively formed left and right-wing orientations. The old Hegelians, such as Rosenkranz, Heym, Erdmann, Fischer, worked to preserve the spirit and solidify the content of Hegel. The young Hegelians, such as Feuerbach, Ruge, Stirner, Bauer, Kierkegaard, Marx, focused more on the historical and personal applications of Hegel's thought. In fact, Hegel's influence was significant outside the institution of philosophy itself in subsequent years, especially in political theory and in the evolution of the social sciences. Rather than prioritizing the metaphysical content, more attention was paid to the historical and the personal, eventuating in the radical revision or total abandonment of the larger Hegelian ideational structure itself. On the larger stage, the post-Hegelian influence on speculative philosophy further entrenched the division of idealist and realist orientations that can be traced back to the attitudes of rationalists and empiricists, and even further to the tendencies of Plato and Aristotle. Along the idealist side, the late 19th and early 20th centuries saw thinkers like Lotze, Wundt, Green, Bradley, Royce, Bosanquet, Ward, McTaggart, Bone, Stout, Croce, Dilthey, Cohen, Cassirer amongst others arrive at perspectives deriving from Kant and Hegel. Various schools, such as absolute idealism, personal idealism, neo-Kantianism, etc., as well as more independent approaches came from this path as well. Basically, the rational, conceptual, transcendent ego is still considered as prior, necessary to what is known as reality. Through the 20th century there were a number of attempts from within this general orientation to encompass the emerging streams of new data and knowledge via novel adaptations and recreation of the idealist apparatus. As well, an emphasis on the qualitative and the ethical components of experience are applied to provide interpretations of meaning, purpose, value consistent with those deriving from idealist premises. However, after Kant and Hegel, philosophy also became more and more specialized and modest in scope. With the historical emergence of science as a primary means of legitimization, much of philosophy became handmaiden to science, with application of theory to the rapidly evolving data of the various empirical fields. The necessity of a transcendent absolute, or a self-sufficient pure ego was deemed erroneous, irrelevant, mere hypothesis. The focus of philosophy was turned to the areas of experience where precise analysis was possible without need for larger framework of interpretation. Speculation was strictly derived from the facts of the type of experience analyzed. Modeled after the scientific framework of logical positivism, philosophers like Wittgenstein, Carnes, Ayers, Carnap, Moore, Ryle, Austin, Strawson, etc., and their followers focused on the minutiae of linguistic usage, habits and processes of thought and behavior, logical connections between intentions and expressions, thoughts and actions, and a variety of other specialized fields of concentration. Other approaches included using strict quasi-mathematical and scientific models of investigation to describe pure experience in itself. Thinkers like Brentano, Husserl, Meinong, Russell, felt reality does not depend on human knowledge of its existence, and that experience is the proper field of study, without necessity of higher orders of explanation. The school of phenomenology used this basic approach, founded by Husserl and incorporated into the methodology of others like Sartre, Heidegger and Merleau-Ponty, who also focused on meaning and value from an existentialist perspective. And directly emerging from the realist tradition, Peirce, James, Dewey, Schiller also took a more modest approach, articulating the pragmatic orientation of philosophy, where practical and experiential criteria were adequate and sufficient tests of truth. More in direct connection with the aims, values, presuppositions of science were the realist philosophers. However, a number of those used the techniques, methods, materials of science to create their own idiosyncratic inclusive systems, where metaphysical speculation mixed with descriptive observation. Bergson, Alexander, Santayana, Morgan, Smuts, Lewis, Quine, Whitehead made notable contributions amongst a group including many others, as well as a number of branches from the idealist, realist schools. The post-Hegelian world of philosophy produced schools and individuals more concerned with values, ethics, meaning, interpersonal relationships than with metaphysics. One direction led to the utilitarian philosophy, as represented by Henry Sidgwick and John Stuart Mill, primarily focused on the pure practical and logistical connections of man and society. More significant historically was the emergence and evolution of existentialism. Nietzsche and Kierkegaard provided the first major personalized formulations of this attitude, where the subjective life of the individual is the primary concern of reflection and analysis. As critical reaction to the encompassing Hegelian systemization, focus was turned instead to the inner conflicts, dualities, enigmas, mysteries of personal experience. In the 20th century, the increasingly depersonalized, polarized, alienated and hostile world environment provided the ground for more and existential reflection, analyses and consideration. Many philosophers from a number of backgrounds make important marks within an existential context. A few notables include Heidegger, Jaspers, Sartre, Marcel, Berdyaev, Unamuno, Merleau-Ponty. Philosophy from the time of Hegel through the 20th century has evolved along many different paths. We have barely even scratched the surface. However, what is important is not the content or validity of any school. The significant thing to note is the shift in general cultural esteem, application, influence of the philosophical envisioning of reality as the prime methodology of legitimization. Philosophy after the Hegelian era became more and more specialized, fragmented into diverse and often clashing schools, more and more relegated to serving academic purpose, focused on the individual, or working upon the data of the sciences. Pervasive social credibility has faded since the time of Kant and Hegel in philosophy as the supreme self-sufficient methodology for an all-encompassing authoritative explication of the nature of reality. Largely because the influx of new knowledge requires continual revision and often specialist expertise in assessment, in the awareness of the limitations of method, and because of a prioritization of more ambivalent personal and value-related issues. The articulation, exploration, speculation of philosophers from the Renaissance to the mid-19th century produced a number of systems and methodologies for envisioning reality which increasingly gave the human ego, powers of reason, role of the individual more self-sufficient assurance and dignity. Whether focusing on the idealist belief in the transcendent status of reason, or the empirical valuation of sense experience and the organizational faculties of the mind, it was the cognitive, experiential, responsible individual who was the subject. And the realm of values, morality, other than rational modes of experience were treated from within the philosophical system, even if by simply being connected by loose theory or having the qualitative dimension projected onto the conceptual apparatus. As a reaction to the legitimizing institution of religion, philosophy provided an alternative set of criteria and techniques, producing a different configuration of the meaning and possibilities of experience. The role of the individual and the power of reason was elevated, while the sense of subordination and trust in faith was qualified. As well, the practical and theoretical importance of rational principles, intellectual thought, practical and social techniques and organization pushed the awareness, training, dependence, expectations of the apparatus of faith more to the background. For partial segments of the culture. For others, less impact meant less change. The institution of philosophy maintained a particular dignity and authority apart but coexistent from the traditions of formal religions and the still evolving fields of the sciences. Chapter 6. And, as we have said more than once, the third cultural legitimizing framework is that of science. And as philosophy and religion interacted historically, science was also part of the mix. However, it was until the synthesis of Newton and subsequent supporting 19th-century theories that science, as such, became the major institutional channel of legitimization in terms of comprehensively describing and explaining what reality was, and how human experience fit into the picture. As has been mentioned, the criteria and methodology of a scientific envisioning of reality derive from a different emphasis on the use of reason as interpreted by philosophy. Valuation of the data of sense observation, taking as a given the legitimacy of the world of appearances, building general conclusions from the observation of particulars are part of the scientific orientation. And more inclusive speculative conclusions, though as theoretical and hypothetical as those of religion and philosophy, are usually presented as grounded on the foundation of observable and verifiable objective fact. In Western thought, especially from the time of the Newtonian synthesis, scientific frameworks of description and legitimization often presented in one way or another a comprehensive mechanistic vision of reality. In mid to late 19th century this perspective was most extreme, self-assured, presented as conclusive and final. During the 20th century the widening scope of investigation in many scientific fields helped modify the absolutism of 19th century thought. Though mechanistic models and assumptions were common in many disciplines, gradually the ambiguities and uncertainties about some aspects of the contents of study and the way observer impacted on interpreting data had an impact on the formulation of scientific theory. For instance, one of the connotations of science which was retained and applied in many areas was that the observing mind was purely separate from the facts of observation. Yet over the 20th century, especially in study of physics, the role of the observer and how data was presented and interpreted became less naively taken for granted as purely outside the equation. As well, no sooner than the 19th century's scientific encompassing materialist vision been extended and expanded, than the new century began a radical revisionism, led by the theories of Einstein. However, we are not focusing on the contents of theories and the degree of facticity as such. Rather we are interested in showing how a particular way of interpreting and representing reality evolved along certain lines. And how science, as a cultural institution, progressed to become the preeminent legitimizing authority in an increasingly secular society. Not the only legitimizing institution certainly, but the one which through the second half of the 19th and the entire 20th centuries appeared most esteemed and emulated in Western society, despite changing contents and perspectives. Going back to distinguishing traits of the scientific orientation, we must return to the context of Greek antiquity. The Milesian philosophers-scientists Thales, Anaximander and Anaximenes are placed at both the beginnings of philosophic and scientific speculative traditions. Reason was perceived as the operative faculty for analysis of experience and speculation about the nature of reality. In fact, there was no hesitation in applying all human capacities in the effort of comprehension and understanding. Religious premises, ethical concerns, the discipline of objective observation of the data of experience, and use of reason to formulate speculative conclusions all were simultaneously active. The Milesians exemplify the tendency of using existing forms, vocabulary, polarities of mythology and religion to provide a framework for presentation and interpretation of data of observation and experience. One common characteristic of their approach was to find the most simple and universal axioms as possible to frame their thoughts. For instance, Thales thought that all things are full of gods, but that reduction of the essence of all things to water was a unitary, simplified and encompassing principle. Anaximander proposed an abstract first principle, the unlimited, as the source of all things. And, although partially mechanistic in nature, it also contains a moralistic component. The idea of a self-sufficient naturalistic substratum of reality called physis is complemented by the idea of moira, derived from the religious and moralistic cultural framework. In viewing all qualities emerging from the unlimited through a separation of opposites, there still was another force equally important. The coming to be, changes, and transformations of the world were ruled by moira, or necessity. And even the gods of mythology and religion were considered under the sway of necessity, emerging and dissolving along with a plurality of worlds under cyclical process, but not in control of the process. And though there was a purpose to the cosmos, it wasn't knowable by human intellect. Only the data of the mechanisms and processes could be observed, not any explicit knowledge or indication of a transcendent purpose. Anaximenes speculated along similar lines, substituting the concept of air as the first principle of the world, the single essential element underlying existence. All other phenomena arose from condensation of air, successively producing wind, cloud, water, mud, earth, and through rarefaction, fire and ether. With the Milesians, the use of observation and sense experience as a significant component of wider speculation is notable. With Anaxagoras and later, the atomists, there is a stricter use of this approach, and more definite examples of what was emerging as a distinctive scientific orientation. Anaxagoras was a follower of Empedocles, and introduced a mechanistic principle of cosmic organization based on the concept of nous, or mind. He followed the premise of Empedocles that what is cannot come from what is not. But rather than reducing phenomena to basic elements, he speculated about infinite divisibility. Each substance was composed of a number of like parts, each of which is infinitely divisible. Yet rather than following this premise to its logical conclusion, he felt there was a final limit of divisibility. These irreducible components were called seeds, which formed the original state of an undifferentiated chaos. It was the ordering principle of mind, nous, which turned these seeds into the structured cosmos. Nous was conceived primarily as a mechanistic process, characterized by activities of separation and differentiation of things and qualities. As well, the emerging and perishing phases of the cosmic process were thought to be false, and that what really was unfolding was the mixing and separation of seeds. The use of observation as basis for speculation can be seen in his theory of seeds. His recognition that particles of food change into parts of the body led to his belief that each seed maintains latent qualities which later manifest. And that all seeds are of a uniform nature, with the same qualities. As well as observation, the results of experimentation also served as input in formulation of ideas. Anaxagoras showed the limitations of the senses in perceiving physical processes by a simple yet clever experiment. He had two vessels filled with liquids, one black, the other white. He slowly moved the contents of one vessel into the other, drop by drop. It was observed that only after the transfer of many drops was the change in color evident. That, although each drop was affecting a change, the unaided senses were incapable of perceiving this as it incrementally occurred. By including principles of both mind and mechanism, use of reason and observation, Anaxagoras led thought in two directions. As we have seen, the central role of mind and reason as the significant principle of order was the basis for the systemization of Plato and Aristotle. The other direction led to the schools of atomism, expounded by Leucippus and Democritus, and formulated into an ethical philosophy by Epicurus. In the atomist's interpretation of the world, true being was considered to consist of both atomoi and the void. Atomoi were tiny irreducible material elements, indivisible, impenetrable, invisible to sight. The void was the boundless empty space necessary for their motion. The valuation of the void as an essential component of reality contradicts Parmenidean logic, but illustrates how the atomists prioritized common sense experience as the foundation of speculation. This trust and dependence on common sense can be seen in these words of Lucretius. All nature as it is in itself consists of two things, bodies and the vacant spaces in which the bodies are situated and through which they move in different directions. The existence of bodies is vouched for by the agreement of the senses. If a belief resting directly on this foundation is not valid, there will be no standard to which we can refer any doubt on obscure questions for rational confirmation. Although Democritus distinguished between obscure and genuine knowledge, the tradition of atomism is firmly oriented towards common sense explanations as a means of knowledge more trustworthy than those with criteria dependent on pure rational logic and deduction. By valuing simplicity and the agreement of the senses, a foundation of reality based on atoms and the void was put in place. One of the theories emerging from this tradition was that atoms were conceived of as qualitatively similar, differing only in shape and size. What appeared as distinctive to the senses was considered to be a result of differences in size, shape, position, and distance between the constituent atoms. The senses were interpreted as receptors of filmy images, which were thrown off the objects and received through direct material contact. Atoms were held to be eternal, moving aimlessly through the void, combining in different shapes as a result of collisions, held together because of their different shapes, which included branched, barbed and hooked varieties. The question of motion was simplified, with the theory of mind introduced by Anaxagoras, and the denial of motion expressed by the Eleatics abandoned as unnecessarily complicated. Epicurus modified Democritus' idea of random motion by considering the possibility of a gravitational force operating in the void responsible for up and down motion. As well, the idea of atoms randomly deviating from straight paths and initiating collisions was thought part of this process. The principle of motion was accepted as an a priori given, an implicit mechanical structural fact, with no clear rationale as to how it originated. Empedocles pondered about forces of love and strife, Anaxagoras about mind, but essentially, an orientation based on deductions from sense observation and common sense logic precluded the need for extensive supplementary speculation. If adequate envisioning could occur without necessity of the support of pure abstract conceptualization, then there was no reason to augment it with non-naturalistic hypotheses. A primary valuation of empirical and common sense knowledge as the most accurate and credible means of interpreting reality helped differentiate the proto-scientific framework from the philosophic as Western civilization evolved from Hellenic to Hellenistic and towards the Christian phases of dominant cultural influence. Besides the prioritization of sense knowledge, observation, experiment, ideal of simple fact-based theorization, more conceptual tools and specialized compendiums of knowledge helped establish a firmer enduring scientific foundation. The theoretical and practical applications of mathematics expounded by Pythagoras, Archimedes, Euclid helped provide additional means for treating and organizing data of investigation. And with biological classifications of Aristotle, the practical physiological approach of Hippocrates, Galen's organizational focus on medicine, Strato in physics, the astronomical investigations of Ptolemy amongst the pioneering efforts of an emerging specialized empirical methodology, a database of knowledge and procedure was gradually being established for an independent and inclusive scientific envisioning of reality. Dodds expressed it this way. In the more abstract sciences, mathematics and astronomy, it reached a level that was not to be attained again before the 16th century, and it made the first organized attempt at research in many other fields, botany, zoology, geography, and the history of language, of literature, and of human institutions. As well as discrete specialist studies and speculation, a wider perception of the relations of the scientific enterprise emerged. The very intention of classifying and connecting the sciences as components of a larger enterprise sharing a similar fundamental spirit and objective was indicative of a unique perspective. Pythagoras and Plato classified according to logical criteria, but Aristotle extended that approach by differentiating between species and genus, and with the formulation of three inclusive scientific categories. His divisions were the theoretical sciences, the practical sciences, and the poetic sciences, and encompassed a variety of classifications within each division. However, Aristotle always presumed that philosophy was the superior criterion of knowledge, with the sciences providing the data for subsequent conceptual treatment. With his pupil, Demetrius of Phalerum, we find a prime example of the pursuit of encyclopedic arrangement and classification, crucial for providing a compendium of knowledge for subsequent study and dissemination. As an organizer of the Great Library in Alexandria, his introduction of divisions and subdivisions of knowledge facilitated specialization in given fields of study. Varro followed during the 1st century BC with the Disciplinarum, possibly the first illustrated encyclopedia. Perhaps the greatest example of the evolving orientation of science as an independent means of knowledge from this era can be found in Pliny the Elder's 37 book, Natural History, from 77 AD. The scientific orientation evolved alongside that of the philosophic as dual perspectives prioritizing particularly conceived configurations of the powers and significance of reason. At the same time, the perspective of faith manifested through a variety of religious frameworks, with all influencing and shaping civic, social, cultural forms. In pre-Christian antiquity, the religious ideational systems most explicitly articulated the specific ways reality was envisioned, though with the evolution of Greek thought, the influx of philosophic and scientific perspectives allowed for renewed and revised interpretation. As well as independent enterprises of thought, both philosophy and science evolved institutionally, with specific traditions, schools of thought, expertise of intellectual specialists, authoritative bodies of knowledge and so on. In general, philosophy often incorporated the materials of science during this time, providing the encompassing ideational worldview within which scientific data was subsumed. Yet a more self-sufficient scientific orientation also was established, often conceptually linked to philosophic or religious systems merely by formal or artificial association. On the surface, incorporated into another legitimating ideational structure, but potentially capable of independent subsistence. In Western civilization, the rise to dominance of Christianity meant that both components of the tradition of reason would have to remain relatively dormant and subservient to the premises and presumptions built into the religious representations of the orientation of faith. Sorokin expresses the fundamental difference in orientation like this. From the standpoint of the revealed truth of Christianity, the truth of the senses and the sensory knowledge derived from it could not appear anything but foolishness. As St. Paul formulates the principle, the wisdom of this world is foolishness with God. Other early Christians and all the Church Fathers designate sensory knowledge as doubtful, uncertain, and probable rather than true. Minucius Felix, as a mere vanity. Basil the Great, as deceit and tricks, babbling, lies, errors, and the like. St. Augustine, as something that is misleading, and finally, as something opposed to the truth. Tertullian, Origen, et al. The clash of these two systems was as sharp as possible and lasted for centuries until Christian faith emerged victorious around the 6th century. This system was not much concerned with empirical knowledge, which was deemed as second-hand truth, being admitted as a handmaid, insofar as it did not contradict the supersensory, superlogical, and superational revealed truth of Christianity. Its simple objective was excellently formulated by St. Augustine. It reduced itself exclusively to the knowledge of God and the soul, such is the categoric formula of this system of thought. Of course, it's an utter simplification to generalize like this without stating that the age of faith in Western culture continued incrementally with expansion, solidification, refinement of scientific knowledge and practice in all fields. However, it was not much more than the methodical work of classification and categorization articulated within the ideational framework of faith. A legitimation of reality is a great chain of being, hierarchically organized according to the premises of religion. As with the philosophic tradition, the scientific orientation was likewise a secondary component of the encompassing and dominant worldview. Yet, with an existent groundwork based on Greek and Hellenistic knowledge, and new influences from Arabic culture, individuals such as Grosseteste, Dietrich of Freiburg, Pierre de Maricourt, Roger Bacon amongst others helped add to the materials of scientific interest. However, the interpretations of meaning, parameters of speculation, practical utilization of scientific data and methods of investigation were strictly shaped by religious criteria. With reason the handmaiden unto faith, as the defining attitude towards science as well as philosophy, only a compromised and handicapped scientifically envisioned picture could emerge. One in which scholastic criteria of inductive logic, teleological interpretation, a doctrinally supported architecture of presumptions and limitations filtered and conditioned any attempt of applying a primarily objective scientific methodology, and the risk of incurring penalties and censure for those that did not conform or make the effort to try and find accommodation within the prevailing authoritative institutional apparatus was an explicitly understood factor. Thus, the intentions of those trying to deal with facts, as objectively as possible, were either cloaked in protective ambiguities, made to fit within existing parameters by compromise or convoluted interpretation, or else presented and open to potentially hostile penalization and condemnation. Again, simplifying the interwoven complexities and nuances of historical development, we shall simply move to the 16th century as a point of departure for viewing science as an emerging autonomous mode of envisioning reality. The political, social, economic, material, and cultural changes coming into effect from the time of the Renaissance, which allowed philosophical thought to flourish, also provided an environment in which pursuit of scientific knowledge was able to unfold on a more secure basis. In fact, both philosophy and science were as yet far less differentiated institutionally, and often were conceived as mutually dependent or related ways of envisioning. In fact, for centuries science was collectively referred to under the term natural philosophy. And though philosophy and science share common valuations and premises about the powers of the conceptualizing mind to provide comprehensive truths, they indeed are distinctive orientations, as we have seen, with unique ideational structures. The prioritization of either the rational or the empirical created distinct philosophical schools of thought, but even more radical differences appeared when the scientific enterprise came to independently envision reality. At times there may be very close parallels between particular scientific and philosophic schools of thought, at other times, dramatic divergence. Yet even when there is mutual support and reification, they remain different prisms for envisioning reality. Whitehead clearly notes that historical distinction in these words. The mind of Europe was now prepared for its new venture of thought. It is unnecessary to tell in detail the various incidents which mark the rise of science, the growth of wealth and leisure, the expansion of universities, the invention of printing, the taking of Constantinople, Copernicus, Vasco da Gama, Columbus, the telescope. The soil, the climate, the seeds were there, and the forest grew. Science has never shaken off the impress of its origin in the historical revolt of the late Renaissance. It has remained predominantly an anti-rationalistic movement based on a naive faith. What reasoning it has wanted has been borrowed from mathematics, which is a surviving relic of Greek rationalism, following the deductive method. Science repudiates philosophy. In other words, it has never cared to justify its faith or to explain its meanings. While philosophic speculation took hold with a renewed valuation of the functions of reason, recognized the dignity and capacities of the ego and the importance of man as rational being in the universe, the scientific advances were often legitimized through practical applications as well as by the soundness of hypotheses and theory. In so many fields, from astronomy to industry, from medicine to physics, science demonstrated its utility and worth. As well, since scientific methods and techniques were based on the principles of observation, experimentation, verification, simple conceptual criteria sufficed. This allowed a common-sense approach and clarity of operation in the deductive process, without need to introduce extraneous theoretical baggage. As the process of secularization grew and affected more and more of the daily lives of individuals, the older unity which religion provided began to dissipate. The premise of an envisioned sacralized hierarchical cosmic order gradually lost persuasive power in light of the new rationalistic and empirical ideational revisions. And even though the religious frameworks still carried enormous legitimating and persuasive powers, were widely influential, and could lead to reprimand for what was considered blasphemous, freedom and independence of speculative thought was gradually taking hold. Religious focus gradually shifted more to the ethical, social and personal dimensions of experience and became more conveniently compartmentalized, allowing for a degree of logical credibility in holding formerly mutua awkward beliefs. With the change in perception from the premise of an inclusive sacred cosmos to recognition of self-sufficient nature, it became possible to maintain religious beliefs as a personal subjective concern while yet investigating the universe conceived of as a purely objective entity. Where the tests of sense experience, common sense, verifiable experiment, were adequate in describing and explaining particular forms of knowledge, wider, more universal speculation often had to draw upon other means of demonstration. That meant the use of mathematical deduction in the fields of astronomy and physics, for example, where observation and sensation were limited, and logical supplementation was needed to provide the widest overviews. Francis Bacon's Novum Organon shows this necessity. It cannot be that axiom established by argumentation should avail for the discovery of new works, since the subtlety of nature is greater many times over than the subtlety of argument. But axioms duly and orderly formed from particulars easily discover the way to new particulars, and thus render science active. We see that the subtlety of nature is essentially more mysterious and complex than it can be represented as, but that by applying the scientific approach rather than pure argument to particulars, the foundation is established. Then, axioms duly and orderly formed from particulars, or the careful construction of logical theories based on scientific study, lead to further expansion of knowledge, and the discovery of the way to new particulars. And as the codification, systemization, embodiment of the expanding database renders science active, it provides precedent for continued progress via the same process. For example, in astronomy, the Ptolemaic vision, revised and reinforced in the Middle Ages, became inadequate in providing a satisfactory interpretation incorporating the new data of astronomical observation and theorization. Despite changing content and ideas, the old system retained entrenched legitimizing status, and provided the parameters of conformity for subsequent speculation. Still, when the cumulative weight of new knowledge overwhelmingly revealed flaws and inadequacies, a more credible orientation had to be sought. Abandoning the confining premises of religious envisioning, the data derived from objective investigation was reformulated along different, more factually adequate lines. Copernicus, Tycho Brahe and Kepler progressively refined the theory of the heliocentric system. And Galileo summed up and articulated a comprehensive vision fundamentally different than the prevailing religious ideational structure. Galileo criticized the teleological and supernatural framework because of their contrived and superfluous criteria and inadequacies in accounting for the new knowledge obtained through empirical process. In practical terms, his system was simpler, clearer, more adequate and credible in accounting for and synthesizing the facts of observation and logic. With verification through observation, and confirming support through the methods of geometry, there was no need to yet again twist facts to fit preconceptions. However, whenever an entrenched ideational system is challenged, revised or supplanted, the repercussions are more than methodically formal. Ideational systems are institutionally embedded, and change often provokes friction and disruption with those committed to maintaining the integrity of the status quo. Arthur Koestler characterizes the situation for Galileo like this. But there existed a powerful body of men whose hostility to Galileo never abated, the Aristotelians at the universities. The inertia of the human mind and its resistance to innovation are most clearly demonstrated by professionals with a vested interest in tradition and in the monopoly of learning. Innovation is a twofold threat to academic mediocrities. It endangers their oracular authority, and it evokes the deeper fear that their whole laboriously constructed intellectual edifice might collapse. They stretch a solid and hostile phalanx of pedantic mediocrities across the centuries. In Galileo's case, the phalanx resembled more a rearguard, but a rearguard still firmly entrenched in academic chairs and preachers' pulpits. Despite having to struggle to gain acknowledgement, the scientific framework of envisioned reality progressively expanded its compendium of knowledge and refined its methodologies. Galileo helped set the tone for future scientific and philosophic inquiry, and remains a pivotal figure in establishing the foundation for a new envisioning of reality. His influence was dramatically felt both in philosophy, by provoking new lines of speculation, and in science, where the example of his methodology and determination of new knowledge served as a precedent for exponential growth. E.A. Burt says this about Galileo's significance. The history of thought must turn to this single individual as the one who, by experimental disproof, overthrew a hoary science, who confirmed by sensible fact a new theory of the universe that hitherto had rested on a priori grounds alone, who laid the foundations of the most stupendous intellectual conquest of modern times, the mathematical science of physical nature, and then, as if these accomplishments were not enough, we must turn to him likewise as the philosopher who sufficiently perceived the larger implications of his postulates and methods to outline a new metaphysic, a mathematical interpretation of the universe, to furnish the final justification for the onward march of mechanical knowledge. Teleology is an ultimate principle of explanation he set aside, depriving of their foundation those convictions about man's determinative relation to nature which rested upon it. The natural world was portrayed as a vast, self-contained mathematical machine, consisting of motions of matter in space and time, and man with his purposes, feelings, and secondary qualities was shoved apart as an unimportant spectator and semi-real effect of the great mathematical drama outside. By establishing the foundation for a new envisioning of reality, Galileo's influences were pervasive. In philosophy, full account had to be made for the radically revised perspective which placed the relationship of man and world in a new light. As we have seen, Descartes grappled with the issues and concluded with a dualistic assessment, trying to equally accommodate the realities of objective and subjective knowledge. And from there, we have seen how both rationalist and empirical schools of thought came out with their own attempts to incorporate the new world being defined by science with the premises of mind as a subjective presence. And even the syntheses of Kant and Hegel necessarily had to deal with the implications of their contemporary scientific bodies of knowledge, as have all subsequent philosophies. And for the scientific endeavor itself, the acquisition of facts, refinement of method, innovations in mathematics, successes in practical applications, theoretical connections between separate fields of investigation all continued to coalesce towards a grand synthesis of mechanical knowledge. In the 17th century, the most ambitious, far-reaching and comprehensive scientific envisioning of reality was articulated by Isaac Newton. Using the conceptual tools of mathematics to tie together and explicate the meaning derived from the cumulative record of scientific observation and experimentation, Newton presented a self-contained inclusive systematic vision of reality. There were others of course who were crucial in adding to the foundation laid by Galileo and the other scientific cosmological pioneers. Perhaps the most significant stimulus to thought came from the evolution of mathematical thought. As Whitehead indicates in these words, this dominance of the idea of functionality in the abstract sphere of mathematics found itself reflected in the order of nature under the guise of mathematically expressed laws of nature. Apart from this progress of mathematics, the 17th century developments in science would have been impossible. Mathematics supplied the background of imaginative thought with which the men of science approached the observation of nature. As with philosophy, science needed conceptual tools to reveal connections and principles. And when science itself was yet natural philosophy, it is not surprising to discover that a number of seminal philosophers were also leading innovators in mathematical thought. Descartes discovered analytical geometry. Leibniz as well as Newton invented the infinitesimal calculus. Spinoza structured his philosophy on the principles of geometry. Thomas Hobbes only pursued philosophy after he acquired an interest in geometry. And most other philosophers were cognizant of both mathematical principles and the facts of science. As well, the dependence on mathematics for scientific as well as philosophical support can be found in the works of Torricelli, Pascal, Boyle, Huygens, Desargues, Fermat, Newcomen, Kepler and many others, who depended on the trustworthiness of mathematics to demonstrate and amplify particular facts and theories into wider encompassing frameworks of meaning. As well, the tendency more towards stricter dependence on experiment and hypotheses themselves without extensive mathematical supplementation was exemplified by Harvey and Gilbert. However, it is with Newton where we find the representation of reality which most completely reflected the spirit and insights of the scientific orientation of its time. Emerging from the same intellectual climate which led to the Kantian synthesis in philosophy, Newton's own scientifically grounded vision embodied a different valuation and interpretation of experience than found in philosophic tradition. As well, with the institution of philosophy till then subsuming scientific knowledge as natural philosophy within its own systems, it retained a more authoritative legitimating status. Philosophers dealt with the facts, theories, premises, conclusions of science, but supplied their own interpretive ideational filters. Only after Newton presented a self-sufficient scientific system could the institution of science attain more independent status. Although philosophers continued to supply their own overviews and evaluations, they were not strictly necessary or required as such. Newton's influence on the contemporary philosophy of his time must be stressed as well. His ideas became part of the intellectual climate, forcing philosophers to re-examine their own premises and deal with a new set of presuppositions and conclusions. Burt observes, now a penetrating study of post-Newtonian philosophers quickly reveals the fact that they were philosophizing quite definitely in light of his achievements, and with his metaphysics especially in mind. The post-Newtonian Western worldview was one in which science steadily ascended in esteem and stature, with religion and philosophy diligently trying to absorb the new stream of knowledge and deal with the repercussions through their own specific conceptual apparatus. However, Newton created one particular model, which itself became subject to dissolution and revision, though the skeletal structure retains legitimating credibility in a variety of amended and reworked forms. Before we look further, it is necessary to trace the characteristics of that ideational system itself. Amongst Newton's prime achievements were the invention of the calculus and formulation of the mathematical model for describing mechanical motion. His use of calculus revealed that in the motion of the Moon there was an exact correspondence with the observable gravitational force of the Earth. This led to the significant postulation that the laws found applicable to phenomena of the Earth were also verifiable mathematically by observation and measurements of the wider cosmos. This conclusion is based on his principle of the analogy and uniformity of nature, which served as a starting premise and ideational presupposition for subsequent scientific investigation. This orientation progressively legitimized the theoretical vision in which the world was perceived to be basically operating through mechanical laws and principles. By reducing all the motion in the universe to the four laws of inertia, acceleration under an impressed force, reciprocal action and reaction, and gravity, Newton consolidated a whole new way of envisioning the cosmos. The Newtonian picture of a cosmos of atomic matter in motion, governed by invariable mechanical laws, fully comprehensible through observation, experiment and mathematical verification became the prime emerging scientific framework for envisioning reality. Astronomy, physics, optics, biology, chemistry and other specialized fields of scientific endeavor were all subsumed as a hierarchy of related disciplines sharing a common ideational climate with generally consistent methodological approaches, evaluative criteria, premises and ideals. The general categorical description of the primary scientific orientation emerging after Newton eventually became known as materialism. With the Newtonian framework firmly entrenched, each incremental addition of new scientific knowledge was conceptually interpreted like a piece of a puzzle, fitting together to coalesce into a uniform worldview. As significant as Newton's framework was for envisioning universal functions, the scope of the scientific approach was extended even more by Charles Darwin's 19th-century biological theories. Darwin's empirically derived classifications and connecting speculative theory of evolution became the major shaping impetus to a new vision of the order and relationships of the diverse species of life. Yet before Darwin, there were other contributions factoring into a revised scientific understanding of biological phenomena. Bernard and Harvey pioneered new perspectives in the investigation and understanding of human physiology, based on mechanistic principles. One of the characteristics of this perspective is that human life was simply a specific form of chemical reactions, differing from other forms of life only by degree of complexity and nature of specific operations. In botany and zoology, Linnaeus, Buffon, Erasmus, Lamarck amongst others pioneered a new naturalistic understanding of the nature of plant and animal life, setting the intellectual climate for Darwin. In the field of geology, through the late 18th and early 19th century, the acceptance as literal fact of biblical linear chronology meant that the age of the earth, evidence of physical transformations, explanation of diversity of phenomena were filtered to fit the facts, to maintain legitimacy. However, through the work of Hutton, Smith, Lyell and others, the principle of uniformity was followed. A purely naturalistic perspective emerged in which natural forces were perceived to be in continual activity over an enormous time span, shaping and reshaping the physical environment. The teleological framed beginning and end of history were found to be inadequate in accounting for details of observation and logical inferences of the data. With Darwin, the data gathered from studies in embryology, experimental breeding, geographical distribution, comparative anatomy, paleontology were synthesized with conclusions drawn from personal observation and experimentation. Through application of scientific conceptual criteria, avoidance of extraneous speculation, his theory of evolution provided a clear, focused, mechanistically based envisioning of biological life. By focusing on structural differences between species, delineating essential functional characteristics, drawing speculative implications from facts, he was able to show a picture of direct evolutionary progress from amoeba to man. By hypothesizing that the changes in species were a result of the accumulation of small variations from generation to generation, either improving or decreasing chances of survival, what was intended as a purely objective description of scientifically determined facts turned into a general conceptual apparatus. Popular characterizations of this framework of envisioning abounded, and notions such as progress, evolution, survival of the fittest, filtered into the mainstream of public thought in a variety of diluted or accurate forms. The concept of progress as a biological fact of nature acquired a much wider significant interpretive connotation when applied in other fields. The displacement of the biblical premise of linear teleological history resulted in a new framework of explanation and evaluation. Darwin characterized his vision of evolutionary change, or natural selection, as a struggle for existence. This connotation, though intended to characterize dynamics of different species interacting environmentally over time, became analogous for all types of human endeavors. Especially when the other part of the equation, the survival of the fittest, was applied. Ethical issues, business practices, political struggles, historical analysis, and a whole range of other issues were interpreted in terms of a popularized application of this concept. Calverton wrote, "Darwin, by virtue of his theory of evolution, succeeded better than anyone in shifting man's concerns from whys and wherefores to nows, from concern with origins to concerns with relations, from concern with purpose to concern with behavior." Many people before Darwin had been concerned with the same thing. But Darwin's work, appearing as it did, impacted the mind of the time in such a way that it helped shift the entire intellectual interest of the century. As part of the interpretive framework of evolution, the notion of survival of the fittest became established as an intrinsic mechanistic principle of existence, or a natural law. Applied to the domain of biology, the Darwinian evolutionary theory represented scientific method fully. Observation of data by the senses, discovery and analysis of supplementary sources of evidence, discarding of extraneous detail and focus on essential elements, use of deductive reasoning and logical connections to formulate a naturalistic all-encompassing theory. With the Darwinian vision incorporated beside the mechanistically oriented bodies of knowledge of astronomy, physics, thermodynamics, chemistry, geology, physiology, biology and other specialized fields, science established itself as a fully encompassing and legitimizing channel for envisioning reality. The elements of the theoretical vision were independently emerging while collectively they shared a common orientation towards analyzing and interpreting experience. For instance, integrated alongside the broad defining approaches instituted by Newton and Darwin were the foundation set by Lavoisier and Dalton in chemistry, Young and Fresnel's undulatory theory of light, Clerk Maxwell's theory of electromagnetism, the cell theory in biology and Pasteur's work on organisms, psychological theories of epiphenomenalism and so on. And while hypothetical theory and speculative conclusions formed part of this ideational foundation, the results of science, in many areas of practical life allowed for a degree of popular dissemination, familiarity, and trust in science as a primary legitimizing authority for envisioning reality. Where philosophy was practiced and formulated by an increasingly fragmented and professionally delimited group of specialists, religion busy trying to fend off and deal with the challenges of science, to its own ideational foundations, the utility and efficacy of science was more and more evident as a reality in everyday life. And with that practical proof of scientific credibility in the increase of new knowledge and proliferation of new and superior inventions and techniques, In the transformational effects of industrialization, came the tacit acknowledgement that scientific progress legitimated the scientific worldview. And with the increase in prestige and credibility of the natural sciences, it followed that the ideal of a unified materialistic scientific worldview would be taken as a paradigmatic model for interpreting and shaping the data of society. Especially after Darwin, a more specialized focus on studying society, scientifically, found form in the foundation of the modern social sciences. Perhaps the positive philosophy of Auguste Comte, the father of sociology, most exemplifies this perspective. Calverton says, Auguste Comte, familiarly known as the father of sociology, aims to study society in the same scientific manner that physicists and chemists do inorganic materials. He is eager to disencumber the study of society from the theological and metaphysical conceptions which have marred the vision of social thinkers in the past, and raise such study to a scientific level where subjective prejudice is supplanted by objective reason. His hope, which is soon to become the hope of all 19th-century sociologists, is to discover social laws which operate with the same inevitability and finality as physical and chemical laws. Like most of his contemporaries, he adds a moral element to his science, to give it human justification, and urges that revealed religion be replaced by a religion of humanity, with the concept of God superseded by that of humanity. The ideal of an objective, impartial and comprehensive methodology mixed with the intentions of enacting tangible real-world social progress and animated by a crusading faith in science as a moral vehicle found diverse expression on a number of fronts. The materialist social philosophy was eminently expressed by Herbert Spencer and Thomas Huxley, who envisioned social life guided by the principles of scientific knowledge and methodology as the most advanced stage in the steady progressive evolutionary climb of the human race. Spencer's influence was particularly notable in shaping early British and American sociological perspectives. As well, Marx fused a revised Hegelian philosophic understanding with a faith in the materialist scientific perspective to arrive at his vision of the nature of class society and the ideals of a progressive transformation. Although the ideals of the scientific method and disciplines moved into the milieu of social concerns, they had their modern roots in the nexus of 19th-century materialism and, as we shall see, attained a new kind of independent credibility. Weber, Durkheim, Veblen, Pareto, Sombart, Proudhon, Bakunin, Buckle, Ward, Robertson, Giddings, Cooley, Sumner amongst others were pioneers of the social thought, bridging the gap from 19th-century materialism to a 20th-century focus on scientific method in the social sciences. 19th-century thought witnessed the maturation of and the seeds of the eventual dissolution of the monolithic materialism of the physical sciences while serving as the breeding ground for the disciplines of the social sciences. Yet during the final third of the 19th century, the intellectual climate was characterized by a sense of near completion, a feeling that all important questions had been, or were being answered via the techniques and methods of the scientific approach. A conviction that nearly all knowledge had been or was being methodically and systematically discovered, organized and made explicable through the fundamental principles, procedures and premises of science. The internal consistency and logical connectivity of the ideational components of this orientation, however, did not retain long-term persuasive coherence. This encompassing ideational materialistic orientation maintained consistent harmonious coalescence for a relatively short time. New facts and new theories provoked radical revisioning in virtually all separate scientific fields, and the cumulative synthetic representation of reality manifesting throughout the 20th century bore little resemblance to the one in place at its start. First, a useful overview of a prevalent mood often provoked by the 19th century materialist vision. Joad wrote about it this way. Copernicus abolished the primacy of man's planet in the universe. Darwin abolished the primacy of man within his planet, and materialist psychology abolished the primacy of mind within man. To the general disparagement of the importance of life initiated by biology and psychology, geology and astronomy were only too ready to contribute. Geology had enormously extended the age of the world, astronomy the size and spread of space. There were vast epochs when it was practically certain the Earth was without life. There were millions of other worlds in which no life was known to exist. Thus in the vast immensities of astronomical space and geological time, life seemed like a tiny glow, a feeble and uncertain flicker, destined one day to be ignominiously snuffed out in the one corner of the universe which had known it. Life, then, is to be regarded not as the fundamentally significant thing in the universe in terms of which we are to interpret the rest, but an incidental product thrown up in the haphazard course of evolution, a fortuitous development of matter by means of which matter has become conscious of itself. It is an outside passenger traveling across a fundamentally hostile environment, a passenger moreover, who will one day finish his journey with as little astir as once in the person of the amoeba he began it. In every direction the material and the brutal underlies and conditions the vital and the spiritual. Matter everywhere determines mind, mind nowhere determines matter. Quote, using the premises and presuppositions of the Newtonian and Darwinian defined scientific worldview, the logical conclusion of that type of speculative procedure produces this kind of self-subsistent materialistic vision of reality. Yet, ironically, this comprehensive materialist worldview did not remain airtight and foolproof very long. With Einstein's theory of relativity but the most notable and socially disseminated repudiation, many of the presumed inviolable premises of the prevailing scientific worldview simply succumbed to a revision in orientation stimulated by the insights of new knowledge. Rather than simply enunciate each progressive step, a few summations reflecting the progressive change in scientific tone and tenor may be instructive. This quote from the first third of the 20th century by Graham Wallas shows that by then the flux of new information and theories in many scientific fields had already damaged the old vision. Graham Wallas summarized this as follows. Within this world discipline, the natural sciences themselves are profoundly changing. All of them are drawing together. The distinction between chemistry and physics has disappeared. Matter is no longer distinguishable from energy. Atoms have become universes, and the behavior of the atom is studied by observation of stars and nebulae. The biologist no longer draws a sharp line between man and other animals, or between animal and vegetable life. And the biochemist tells us that when dealing with viruses and ferments he can no longer distinguish between chemical and vital activity. Toulmin and Goodfield have this assessment of the status of scientific knowledge from near the end of the second third of the 20th century. Today we can see, forming under our hands and eyes, the possibility of a reunified view of matter and life. And this is so just because our fundamental assumptions of matter have gone beyond both Aristotle's and Newton's. For us, matter is intrinsically neither developing nor inert. Potentially, it can be either the one or the other. The chemical elements, as such, are neither organic nor inorganic, they have it in them. Equally to form gases and crystals, viruses, DNA, and cells. And this reordering is no mere quibble. Our theories of matter have been transformed down to the very root. Classical 19th century science was still in crucial respects a Democritan system. It treated the atoms of matter primarily as bricks. There is no such Democritan bias about contemporary wave mechanics. The physicists' fundamental units are no longer bricks. They are now dynamic units, defined by characteristic patterns of energy and activity. We find in nature a hierarchy of active forms, which runs from subatomic wavicles, through atoms and molecules, nucleic acids and viruses, to cell parts and cells, organs and complete organisms. The sequence is not closed at either end. At every level of analysis, from protons and electrons up to living creatures, the objects which nature is composed of have to be characterized in terms both of their structures and of their activities. And from the last decade of the 20th century comes this perspective by Fred Alan Wolf about the envisioning of reality through the framework of contemporary scientific knowledge. I have been studying quantum physics for a long time and have been very interested in how consciousness and quantum physics overlap. I am specifically interested in something which is well known in quantum physics as the observer effect. A quantum system usually exists in a superposition of states. These states correspond to the observable and thereby measurable attributes of our experience of the world. For example, there are states corresponding to the location of physical objects. Before they are observed, these states exist as a ghost-like wave cloud of possibilities, spread over space and time like a mysterious fog. Physicists call this fog a superposition of quantum waves. Suddenly, upon perception, observation, or cognition, this multitude of states becomes a single state. This is called reduction of the wave packet. This means that once a state is known, its wave of probability must become singular, spiked, at one place and time, rather than being diffuse and spread over space and time. When this spike occurs in a wave, the object takes on a physical appearance and the observer of that object has a cognitive experience. But no one knows just how this sudden, spiky reality appears. There is nothing in quantum physics itself that predicts this occurrence. This sudden spike of reality is the basis of the Heisenberg uncertainty principle and has given rise to many different interpretations. These quotes are a reflection of an attitude found throughout the 20th century, based on factual developments and subsequent revisions of scientific fundamentals. The methodology of science was respected, honored, authoritative. Yet the absolutism and dogmatic vision of 19th-century materialism has been undermined by perspectives acknowledging more of a sense of mystery and ambiguity. As the data of experiment and observation becomes less firmly definable in the older objective terms, new factors shape different representations. And the role of the subjective observer likewise becomes a prominent part of the scientific theoretical mix. Science, as both the repository of worldview explanation and the guide to social betterment, clearly stood as the dominant legitimizing authority through the 20th century. While content changed, revised visions were compiled, renewed scrutiny of method was practiced, the eminence yet remained. This quote from Polanyi's book Personal Knowledge illustrates the recognition of the scientific enterprise as an ideational system which is founded upon a set of tacitly held presuppositions. Science is a system of beliefs to which we are committed. Such a system cannot be accounted for either from experience as seen within a different system, or by reason without any experience. Yet this does not signify that we are free to take or leave it, but simply reflects the fact that it is a system of beliefs to which we are committed and which therefore cannot be represented in non-committal terms. Leading up to this position, the logical analysis of science decisively reveals its own limitations and points beyond itself in the direction of a fiduciary formulation of science. The scientific worldview is not necessarily the purely objective cumulative recordings of the data of senses observation and their logical inferences. It is an enterprise practiced by individuals who bring their own sets of assumptions and expectations. The ideational framework is a system of beliefs to which we are committed. It is not just a matter of assuming the premises and methodologies are intrinsically all-encompassing or absolute means of representing all facets of reality. It is a system of beliefs to which we are committed, and thus must be seen through the lens of self-scrutiny and continued reflection, and cannot be represented in non-committal terms. The enterprise of science as it continues to reshape and re-envision a particular construction of reality must factor in its own limitations, and maintain a quality of adaptability. So it points beyond itself, as it appears at any given time, aspiring to a fiduciary formulation of science, as an always processional multifaceted operation. However, Despite questions about the all-encompassing credibility of the consensus scientific worldview consolidated in the 19th century, a large percentage of scientists and philosophers of science have rabidly defended the essence of the materialist vision. Whether by ridicule of alternative scenarios, attempts to tweak old theories with new data, or changing the definitions of terms and standards of proof. A visceral distrust of anything that could undermine dominant authoritative status of that vision often reverts back to a revival of centuries-old disputes between the institutions of religion and science. Maintaining a specific status quo has always been something that is not willingly surrendered. As the 20th century unfolded, foundational issues became once again more open and fluid in the physical sciences. The emerging disciplines of the social sciences each experimented, refining procedural methods, constructing sets of guiding principles, produced bodies of knowledge reflecting particular orientations and objectives. Creating science, as defined in the history of the physical sciences, was the preeminent ideal. But the more ambivalent fields of human production, behavior, conduct, creation, perception provided less secure footing and thus less uniformity or unanimity in authoritative speculation. By the 20th century, professional philosophy had receded to a sphere of influence largely centered in academic circles. And in that mainstream context, did have degrees of indirect or tangential influence with specialized groups and individuals. And while continental philosophy prioritized issues of subjective concern, British and American schools largely placed an emphasis on problems of linguistic clarification and the implications of scientific knowledge and procedure. However, the institution of science, while yet maintaining its own class of experts, specialists, authorities, and adding to the bodies of ever-increasing knowledge, was able to filter, simplify and popularize its general concepts enough to persist as the primary source of legitimization. Philosophical support and critique helped explicate and contextualize the issues for the specialist but often the mass public was more cognizant of the technological products and effects of scientific endeavor than of the quasi-esoteric theory supporting the ideational structure. The religious and the scientific frameworks held sway over the larger populace from mid-19th through the 20th century. While the religious systems were unable to apply the same consistent type of secular objective envisioning of the world as science, they still held large influence in terms of moral issues and spiritual concerns. Issues of faith were able to be maintained in conceptually separate categories from facts of science, for many, as the struggle to authentically incorporate both ideational streams produced a number of hybrid or compromised positions, and even where the metaphysical components of the doctrinal religious frameworks were discarded, amended, reinterpreted or kept in the background, the ethical and experiential compendium of ideas still provided many with satisfactory material. As well, for many envisioning reality primarily through the prism of science, issues of value, meaning, ethical concern were fully accounted for from within the scientific purview or with supplementation from philosophical sources. A number of secular ethical and humanistic approaches incorporated issues traditionally dealt with by religion, or rephrased the questions without the same premises and presuppositions. We have now noted the rise of the scientific spirit and methodology. Growing and evolving simultaneously with the religious and philosophical traditions, the unique characteristics distinguishing the scientific from other outlooks was the importance of sense observation, experiment, hypothesis, and an objective clarity and detachment, in which theories can be discarded as new facts and insights appear. Largely overshadowed by religious and philosophical comprehensive worldviews, nonetheless, by the time of the Renaissance and the subsequent secularization of Western society, science rapidly became both a practical and a theoretical framework of importance. Especially through the practical uses of new scientific insights, its legitimizing authority grew in prestige and importance, though provoking hostility and suspicion from entrenched institutions of knowledge. And while Kant and Hegel were cementing the foundations for their comprehensive all-encompassing philosophical visions of reality, first Newton and soon Darwin were respectively synthesizing and classifying the data of physics and biology. And with the inclusion of many other strands of specialized scientific study, an inclusive comprehensive worldview of its own fell into place. The 19th century vision was a hybrid of both fact and theory. In the end, the logical positivism of Comte typifies this ideal of an entirely mechanistic and materialist worldview, which was as much an attempt to legitimize the sanctity of the applied scientific method as it was an enunciation of knowledge. And like the Hegelian systemic extravagance and the dominant otherworldly religious edifices, the monolithic materialist vision did not retain that same persuasive and unchallenged legitimating assuredness even early into the 20th century. A host of new discoveries, perceptions, theories, reflections on events in a wide variety of disciplines undermined the airtight worldview embodied in the materialist vision. Yet at the same time as many of the discrete facts and inferences of the materialist ideational structure were being realigned, reconfigured or removed, the ideal of the scientific method was still operative and dominant as the most credible means of attaining factual knowledge. It sustained its esteem as an ideal approach to the acquisition and systemization of information pertaining to the nature of human social and personal existence, with a number of new disciplines being brought under a more systematic umbrella. The natural, or physical, sciences were joined by the social sciences, which moved to the academic milieu as disciplines with their own sets of premises, procedures, trusted bodies of knowledge and opinion. And while the methodology may not be equally well suited for all the types of data under study, the attempt to treat the subject matter objectively and dispassionately has been a dominant ideal. And with the seemingly perpetual revolutions in scientific knowledge throughout the 20th century came a tendency towards a more introspective analysis of the very process of scientific procedure, and the variables relating to the role of the observer on the data studied. As well, within particular disciplines, a more open and exploratory approach to the study of consciousness has characterized a new orientation. As the dominant legitimating institution, with an extensive database of traditional knowledge, honored personages, sacrosanct principles, diverse authoritative schools and experts, it would be naive to imply that there is a uniform encompassing envisioning of reality with unanimous accord. Or that all trends and shifts have led in exactly the same direction. Within the institution of science, as with religion and philosophy, there coexist a number of perspectives prioritizing different facets of the database of knowledge and citing diverse authorities from specific schools in support of a particular approach or conclusion. And at the end of the 20th century there remained such types of allegiance as well. However, looked at in terms of general tones, tendencies, trends, particular dominant themes and directions can be discerned. As well, it should be stressed that there will always be a time lag effect between the time the most recent knowledge is acquired and the time it filters through to mass public awareness. And in many cases, the actual popularized dissemination of ideas is less precisely articulated or accurately understood in all its ramifications. Yet by the end of the 20th century, the overall envisioning of reality through the ideational structure of science was in essentials very different than that in place at the beginning of the century. The scientific approach within the tradition of reason was still operative and determinative of the way knowledge was acquired and articulated, but the closed self-contained boundaries of the 19th century vision were repudiated through new insight and knowledge. And because of the fluid evolving condition of scientific knowledge throughout the 20th century, many different perceptions of what science said about reality coexisted virtually simultaneously at all levels of thought, adapted and evolving with each new insight or discovery. At the expertise and specialist level, a number of plausible hypothetical theories emerged. At the popular level, a wide range of both fact-based and sensationalistic speculation resulted in a variety of positions. However, Common to all was a respect and esteem for the scientific enterprise, and a faith that scientific procedures were the most credible means of obtaining factual knowledge. In the ideational interplay with religion and philosophy, science maintained a more authoritative status as definer, reality, taken as an encompassing totality. However, it may also be recognized that for many people, their feelings about the nature of reality derived from more than one source. The further one analyzes, the more diversity and variation will be revealed, though overall tendencies do indeed exist. And when examined, it is very easy to find that the hierarchical mixes of legitimating channels will be shaped by influence of many variables. Geographical location, time frame, social and economic status, family dynamics, educational status, and so on determine the prioritization of legitimating institutions. Very generally, it may be seen that the tendencies in Western civilization have moved from phases of ascendancy of religion to philosophy to science. Yet, as we have mentioned, at all times a plurality of orientations exist. Perhaps a somewhat simplistic, though generally accurate assessment of the traditions of faith and reason at the end of the 20th century may be that each institution, though aspiring for inclusiveness, has maintained a specialized affinity for particular types of knowledge and interests, which have dramatically shaped how all other knowledge is conceived, interpreted, evaluated. As well, it should be noted that a perennial theme often recurring whenever there is an attempt at an inclusive overview of knowledge is that past is projected as being a foundation needing corrective attention so that more pertinent and accurate forms of envisioning may be expressed. This attitude may be found within specific traditions and schools as part of the process of adaptation and revision. As well, it may also be found independently, where different assessments and formulations occur. For example, in this quote from Oliver L. Reiser, we find the belief that knowledge of the past is just a foundation upon which a more accurate and relevant ideational structure can be built. Looking at the situation in long-range perspective, we realize that as old concepts lose their absoluteness, novel and modified views of the universe arise to take their place, and man's understanding grows apace. What this means philosophically is that with increasingly wide experience we may move closer to some all-embracing and more objective systems of ideas about man and the universe, a worldview that can possess a greater measure of universality than earlier and more parochial systems of science, philosophy, and religion managed to achieve. The words most appropriate for our purposes are, as old concepts lose their absoluteness, novel and modified views of the universe arise to take their place. We are interested in following the transitions in the way reality has been envisioned, and how the legitimating ideational institutions have articulated particularly shaped and filtered representations of reality. The merits of one or another claim fall outside the scope of this project. We have briefly illustrated some of the defining characteristics of the parochial systems of science, philosophy, and religion, as they have expressed a unique Western configuration, in which the potencies and ideals of faith and reason are dominant determinative factors.